Hello everyone! Today we will introduce how M467 switches between multiple applications. Of course, it is also applicable to other series of chips. In customer applications, it is often necessary to switch between multiple programs, for example, between LDROM and APROM, or even within APROM. Whenever a program switching error occurs, it often takes a lot of time to identify the root cause, and developers may lack a clear direction for troubleshooting. By being familiar with the principles of program loading and execution and understanding which program switching methods the current chip supports, you can achieve reliable program switching and avoid issues such as switching failures, unexpected jumps, hard faults immediately after switching, or hard faults triggered by interrupts. Let's take a look at the agenda first. Today's content is divided into 4 parts. The first part introduces the principle of program loading and execution. The second part introduces the method of program switching. The third and fourth parts introduce examples and execution results of M467 multi-program switching. First, let's talk about the principle of program loading and execution. Let's explain program compilation. The program size generated after compilation is divided into 4 parts. Code represents program code, RO represents constants, RW represents global variables with non-zero initial values. CI includes global variables with 0 initial values, stacks, etc. The ROM stores code, RO, and RW, which are the parts programmed into Flash. RW and ZI are stored in RAM and do not exist during programming. They only appear during loading and execution. Let's look at the loading address and execution address. The loading address is the address where the binary file is programmed to Flash. The execution address is the address where the program is executed. For example, in the following image, both the loading and execution address are set to 0x00000000. From the loading view, you can see that only ROM is used here, and it starts from address 0x00000000, and the binary file is saved. Including RO and RW, RO contains code, constants, and the initial values of global variables. From the execution view, we can see that both ROM and RAM are used here. ROM contains code and constants, while RAM contains RW and ZI. Next, let's talk about how to set the load and execution address. The first method is to set it on the target page. First, select the Use Memory Layout from Target Dialog option in the linker page. Then, set the starting address and size of ROM and RAM in the target page. The second method is to set it directly in the linker page. The third method is to use a scatter file to define the loading and execution address. Select the option to load files separately in the linker page. The definition of scatter file is shown in the figure. Next, we talk about how the program is loaded and executed. First, after power on, it must be executed from address 0x00000000. Load SP from address 0x00000000, then load PC from address 0x00000004. You can see that address 0x00000004 stores 0x255. Then jump to the address indicated by PC to start executing the program. You can find the corresponding line of code from the assembly window. Select this line, and you can see from the window below that it actually corresponds to the reset handler underline function. Next, start executing the reset underline handler function. The reset underline handler function will call system function to load the program and initialize RAM. For example, the loading and execution addresses set in the following figure are all address 0x00000000. Firstly, load the program and constants with physical address 0 to the execution address 0. Then copy the global variables with initial values from the RW area of ROM to RAM. Finally, initialize the ZI region to 0. After initialization is complete, the application program begins to execute, and when an interrupt is generated, it jumps to the vector table to find the address of the interrupt handling function. we have discussed the loading and execution of programs. You should understand the necessary conditions for the correct execution of the program. First, the loading and execution address must be set correctly. Second, the program must be programmed to the set loading address. Third, ensure that there must be a program at address 0x00000000. Fourth, the vector table must correspond to the current program. Otherwise, if the corresponding interrupt function cannot be found after the interrupt is generated, a hard fault will occur. It should be noted here that the interrupt vector table of M0 must be at address 0. The default vector tables of M23 and M4 are also located at address 0. However, they have the function of modifying the offset of the vector table, which can change the position of the vector table during operation. Therefore, no matter M0, M23, or M4 is powered on, it will start from address 0. Next, we will discuss the program switching method. Through the previous introduction, we understand that the essence of program switching is to replace the vector table and restart the program from the new interrupt vector table. Then, a new question comes. First, how to replace the vector table. Second, how to start executing the program from the new vector table. There are 4 methods to replace the vector table. Select boot mode, vector remap, bank remap, set VTOR. There are 2 methods to execute the program from the new vector table. One is software reset, and the other is program pointer jump. Both methods are very simple and will not be explained in detail. Next, we will explain in detail 4 methods for replacing vector tables. Let's look at the first method, setting the boot mode. Nuvoton chips generally have LD-ROM and AP-ROM flash for storing programs. Therefore, you need to choose which flash to boot from, that is, choose the boot method. Let's take a look at the image on the right, which is the memory distribution diagram of M460. LD-ROM has a small space and is usually used to store the customer's bootloader. From the figure, you can see that the M460 series LD-ROM has 8K, and the starting address is 0x0F10000000. AP-ROM has a larger space and is used to store user applications. Of course, you can also put both the bootloader and the application in the AP-ROM. The AP-ROM of the M460 series has 2 types, 512K bytes and 1024K bytes. The physical starting address of the AP-ROM is 0x00000000. The boot mode is saved in the CBS bits of config 0. When powered on, the configuration will be read from config first, and the program will be executed from the set boot position. There are 4 options for boot mode, namely LD-ROM without IAP AP-ROM without IAP LD-ROM with IAP AP-ROM with IAP. It should be noted that the M460 series only has LD-ROM with IAP and AP-ROM with IAP. Choosing to boot from LD-ROM or AP-ROM is easy to understand, which means starting the program from the selected memory region after power on. Let's explain the difference between without IAP and with IAP. Without IAP refers to treating the LD-ROM and AP-ROM as 2 independent memory regions that are not visible to each other. The starting addresses are all 0. Whether it is an LD-ROM or AP-ROM project, the load execution address can be set to 0. Set to without IAP mode, program jumping between LD-ROM and AP-ROM can only be achieved by modifying the boot location. With IAP, the LD-ROM and AP-ROM are considered as a single block of memory, visible to each other. The first address of AP-ROM is 0, and the first address of LD-ROM is non-zero. For example, the starting address of LD-ROM in M460 is 0x0F100000. So, if it is the M460 series, in order to set the loading and execution address of the program to the LD-ROM, it must be set to 0x0F10000000. Setting it to with IAP mode not only allows for program switching between LD-ROM and AP-ROM by selecting the boot mode. Vector remapping can also be used to achieve this. If it is an M23 or M4, VTOR can also be set to achieve program switching between LD-ROM and AP-ROM. There are also 2 ways to modify the boot mode. The first method is to modify the config, which will be saved when chip is powered off. After modifying the conif, the chip needs to be restarted for the settings to take effect. The second method is to modify the register. After power on, the CBS bit of config 0 will be loaded into the BS bit of register FMC_IS PCTL. Program switching can be achieved by modifying BS and then resetting CPU. The value of the register will not be saved when it is powered off, so the boot set in this way will not be saved when it is powered off. Also, it should be noted that not all chips have a BS bit. Without a BS bit, the second method cannot be used, such as the M460 series FMC_IS PCTL registers, which do not have a BS bit. Next, let's introduce the second program switching method, vector remap. Vector remap is to map the 512 bytes of the specified address to address 0. Through vector remap, the vector table of other programs can be mapped to address 0, and the program at address 0 can be executed by CPU reset or program pointer jump to achieve program switching. It should be noted that the vector table of the M460 series exceeds 512 bytes, and the vector table cannot be completely mapped using the vector remapping function. If you want to use vector remap to switch programs, after switching to the new program, you should set VTOR to the original position of the program's interrupt vector table before enabling interrupts. Otherwise, if the interrupt is not within the first 512 bytes of the vector table, a hard fault will occur. Next, let's look at the third method, bank remap, which is used to determine whether the starting address of bank 0 or bank 1 of the AP-ROM is used as address 0. For example, in the picture, you can see that the physical address of bank 0 is 0, and the physical address of bank 1 is 0x80000. When bank remapping is set to bank 0, the virtual address and physical address coincide. That is, the virtual address of bank 0 is address 0. The virtual address of bank 1 is 0x80000. When bank remapping is set to bank 1, the virtual address of bank 1 becomes 0, and the virtual address of bank 0 is 0x80000. When performing bank remapping in one bank to switch to another bank, it is important to ensure that the current locations of both banks have the same program. Otherwise, after the bank is mapped, continued instruction fetching will fail and generate a hard fault. For example, there are 4 programs, Loader 0 and App 0 are placed in bank 0, and Loader 1 and App 1 are placed in bank 1. Set the starting address of bank 0 to 0. When Loader 0 is being executed, bank mapping is performed in the program, and bank 1 is mapped to address 0. At this time, the instruction fetched is actually the instruction at the corresponding position of Loader 1. If Loader 1 and Loader 0 are different, it will fail to fetch instructions and enter a hard fault. Only when the two programs are exactly the same will there be no instruction fetch error. Next, let's talk about the fourth program's switching method, vector table offset. VTOR is used to specify the location of the vector table. Its initial value is 0, so the program always starts from address 0 when powered on. M23 and M4 support modifying the interrupt vector offset, while M0 does not. After modifying VTOR, program switching can be achieved through program pointer jump. Next, we use a table to summarize all the program's switching methods introduced and the situations in which they can be used. For example, switching between LD-ROM and AP-ROM can be achieved by modifying the boot mode, vector remap, vector table offset, or bank remap. Vector remap and set VTOR can be used between internal programs in AP-ROM without dual bank functionality. Double bank programs switch through bank remap. The program switching between LD-ROM and SPI flash can be achieved by setting VTOR. If switching from SPI flash to LD-ROM, you can also modify the boot mode and vector remap. The switching method between AP-ROM and SPI flash is the same as that between LD-ROM and SPI flash. If AP-ROM is dual bank, bank remap can also be used to switch from SPI flash to AP-ROM. Next, we will introduce the M467 multi-program switching code. The code mainly consists of 5 projects, which realize the mutual switching of programs between LD-ROM, AP-ROM Bank 0, AP-ROM Bank 1, and SPI Flash. Switching from AP-ROM Bank 0 or 1 to APROM Bank 1 or 0, SPI Flash LD-ROM. AP-ROM Bank Internal Switch. Switch from SPI Flash to AP-ROM Bank 0, Bank 1, and LD-ROM. Next, let's introduce the first project, Bootloader. Due to the bootloader exceeding 8K, part of it is placed in the LD-ROM and the rest of the program is placed in the AP-ROM. Also, because the AP-ROM uses a dual bank function, it is necessary to place it in the same position on both banks of the AP-ROM, otherwise it will cause abnormal operation. Use the scatter file here to set the loading execution address. Select the program and switching method through UART input. Distinguish the currently executing program by the printed information and the flashing of the LED. If you want to boot from the LD-ROM when powered on, you can also set the boot mode to LD-ROM with IAP and Q. Loader is the boot program and AP-ROM. Put them separately at addresses 0 in 2 banks. We use this program to switch between 2 banks, so the program for this position of the 2 banks needs to be the same. Set the loading execution address to 0 in Linker. By selecting the Settings button on the Utility Selection page and choosing Use Bank 1 or Not in the pop-up dialog box, the program can be programmed to 2 banks separately. Select the program and switching method through UART input. Distinguish the currently executing program by the printed information and the flashing of the LED. A PP0 is an application program stored in AP-ROM Bank 01. The program is located at address 0x4000 in Bank 0. Set the loading execution address to 0x4000 in Linker. Set the programming location to Bank 0 in Utilities. Select the program and switching method through UART input. Distinguish the currently executing program by the printed information and the flashing of the LED. A PP1 is an application program stored in AP-ROM Bank 1. The program is located at address 0x4000 in Bank 1. Set the loading execution address to 0x4000 in Linker. Set the programming location to Bank 1 in Utilities. Select the program and switching method through UART input. Distinguish the currently executing program by the printed information and the flashing of the LED. A PP2 is an application program in SPI Flash. Stored in SPI Flash. Set the loading and execution address in Linker to 0x100000. Select the program and switching method through UART input. Distinguish the currently executing program by the printed information and the flashing of the LED. Next, let's introduce the main code. Because the registers related to FMC are protected, the first step is to unlock the registers. As mentioned earlier, the interrupt vector table of M467 exceeds 512 bytes, and vector remap cannot map the complete interrupt vector table to address 0. So before enabling the interrupt, it is necessary to modify the offset of the interrupt vector table to the correct position. Next, let's look at the implementation of program switching. Regardless of which method is used for program switching, it is recommended to disable all interrupts before switching. When disabling interrupts, both the interrupt vector and total interrupts need to be disabled. The first method is bank remap, vector remap, and CPU reset. Method 2, vector remap and CPU reset. The first method includes an additional statement for bank remap. The third method is bank remap, vector remap, program pointer jumping, and the fourth method is program pointer jumping after vector remap. The difference from the first 2 methods is achieved through direct PC redirection. Next is the fifth method, bank remap, modifying VTOR, program pointer jump. The sixth method is to modify VTOR and redirect the program pointer. The last method is to modify the boot mode in the config and reset the chip to implement program switching code. This is the result of program execution. The left picture shows the result of executing the bootloader program in the LDROM. If you want to execute the bootloader when powering on, just set the boot mode to LDROM with IAP and cone of 0. According to UART prompt information, after entering A, the program jumps to the Loader 0 program in APROM and prints out the debugging information of Loader 0, as shown in the right picture. After entering A to K according to the prompt, it will jump to the specified program in a selected way. Today's video is over. Welcome to Scan the Code to follow Nuvoton WeChat account and get the latest product information and event information.